Here is how Zener diode used as voltage regulator, that is compensating increase or decrease in voltage, keeping output voltage constant. So line regulation in Zener regulator. Zener diode हा voltage regulate करण्यासाठी, voltage constant ठेवण्यासाठी कसा वापरला जातो, म्हणजेच तो voltage input voltage मधलं व्हेरिएशन कसं कॉम्पेन्सेट करतो. फर्स्ट एक्झाम्पल. Here, even though input varies, how it is used to keep output voltage constant. So Zener diode as a line regulator, effect of supply voltage variation, how it is compensated. Here, input voltage is given varying from 80 volt to 110 volt. Zener diode is used of 50 volt. Yes, regulated expected output voltage will be 50 volt. Zener diode is used in reverse bias, as here it is the positive negative terminal of this input voltage, cathode is connected to positive, anode negative, RS of 5 kilo ohm. As we know, according to KCL, here IS gets divided into two branches, IZ and IL. RL is shown of 10 kilo ohm. So output voltage across RL is to be kept constant. Here it is. If VI varies from 80 volt to 110 volt, expected output voltage constant is 50 volt. So first condition, as Zener diode and RL both are parallel to each other, whatever is Zener's breakdown voltage will appear across RL. Correct. So VL is nothing but output voltage, that is equal to VZ, which is IL into RL. So IL can be calculated as VO upon RL, that is VL upon RL, that is nothing but VZ upon RL. So 50 upon 10K, 10 into 10 raised to plus 3, here it shows 5 milliampere current. So how much is the IL? IL is of 5 milliampere. Now consider V in to be 80 volt. It is greater than VZ. V in 80 volt, so VL expected, it will remain constant 50 volt because both are parallel to each other. Now, how does internal current variation occur? As VRS is equal to V in minus VZ, 80 volt minus 50 volt, across RS 30 volt will get dropped. So how much will be the current through RS? That is IS. IS is equal to VRS upon RS, 30 volt upon 5K, it results to be 6 milliampere. As IS is equal to IZ plus IL, IS we calculated 6 milliampere, IL is 5 milliampere, it will remain constant. So IS is equal to IZ plus IL, therefore IZ is calculated as IS minus IL, 6 milliampere minus 5 milliampere, it remains 1 milliampere. When Vin is 80 volt, voltage drop across RS is 30 volt, output voltage 50 volt, IZ 1 milliampere. This is the first calculation. Second calculation, consider increased 110 volt, then voltage across RS also gets increased with 60 volt. IS increases 20 milliampere, so IZ increases, it becomes 7 milliampere, but I remains constant. It is kept constant 5 milliampere. So here that is Vout remains as constant 50 volt. Thus Vout constant as 50 volt and I constant as 5 milliampere. So here we can observe an increase in IS occurs, IZ gets increased, but IN is kept constant. So in this way, whatever variation in input voltage occurs, variation in IS occurs, and that variation is compensated in Zener diode, keeping IL constant, and thus here I into RL, this voltage drop remains constant. So this is known as the line regulation action in Zener regulator, or effect of supply voltage variation using Zener diode how it is compensated. Next example we will solve regarding change in RL. Zener diode used to compensate load variation. That is load regulation action in Zener regulator. Effect of load current variation. Here is shown 100 volt. RS series resistor to have voltage drop more than VZ when V is applied. Zener diode is connected in parallel with RL as well as used in reverse bias. I am connected to negative, I am connected to positive terminal. RL is shown value. That is, change in RL is such that RL varies from 1 milliampere to 8 milliampere. So first, when V is fixed, gain is not changing, then it is the 100 volt. Therefore, VRS equals to gain minus VZ as 50 volt. So VRS 50 volt constant. As VRS is constant, RS has to be constant. It is adjusted by Zener diode. As VRS is equal to 50, IS it can be calculated as voltage across RS upon RS. 50 volt upon 5 that results to be 10 milliampere. So here RS is kept constant. For voltage, it is of 5 to 10 milliampere. As VRS is constant, voltage across RS remains constant, so IS remains constant. Now, first case, suppose RL is adjusted such that IN is 1 milliampere. As IZ is equal to IS minus IN. IS 10 milliampere minus 1 milliampere, then IZ becomes 9 milliampere. IL was 1 milliampere, so IZ resulted as 9 milliampere. Next, IL gets increased 4 milliampere, then IZ results to be 6 milliampere. Now, as IL again increased to 8 milliampere, then IZ becomes 2 milliampere. So what is the observation? As IL here it is dependent on IZ. IL increased same percentage, but in opposite way, IZ will change. Increase in IL makes IZ to